So a little bit on the strategy now. We're going to actually take and manipulate a polygon just to move these 3 points over and then flatten that polygon out and then reattach the adaptive components again to the same points. So the way we're going to do that is, let's just take, for instance, let's gather back our polygons. And what we can do is Dynamo will allow us some functionality here that will allow us to get some critical reference points. What we want to do is find a reference plane to rotate this polygon to. And I'm going to go through one way. There's probably a bunch of ways to do this. But one of the things we can find right away is a center point for the polygon. And that gives us a way of using that as a reference to move the polygon around. So I typed in polygon center. And if we put that in to this, now appears a polygon point. And the next thing we want to do is actually just generate some idea of a reference plane to that. And so we're going to take this curve now and make a surface out of it, because we're going to need a surface for another function, which is to get the normal point out. So just bear with me a little bit here. Let's go curve by patch, or XUR. So once I have this up here, I'll show you what it does. We're going to take the polygon and treating it as a curve, and what it's going to do is just make a solid out of the whole object. So we have this solid now with a reference point in the center of it, and we have a function which is called the surface normal at a point. So we have a surface now and a point, so we can get a normal, a vector coming off of that. And we need that vector because that's how we're going to rotate these reference planes around. So I'm going to type in now surface and dot normal and at normal point, and we get this, and that's going to give us a vector off of that. So if I plug in surface and point, I don't think we'll get anything. We're going to get a vector, and the vector doesn't appear. But the next step will give us something that will appear. We're going to get that reference plane. So I'm going to go plane dot by origin. And I don't really expect you to think that, oh, this is something easily I could pull up on my own here, because this is going through this process. So this whole idea of this vector manipulation of finding surfaces and then rotating surfaces takes a while to really understand. So I'm just taking you through kind of a live demonstration of this whole activity. Okay, so now I've connected. So what I've done is I've taken that surface normal point, a vector coming out of here, and at that origin point, so the vector and the point, and now I have a reference plane. And the idea here is, because now I have my surface and this reference plane, I can take this whole thing and alter its geometry. But there's a little bit more that has to happen before we go to that. We have to actually take this plane now and move it into a coordinate system. That coordinate system that we'll eventually be able to manipulate. So I'm going to go plane to coordinate system. Oops. Dot to coordinate system. And it'd be interesting to see what comes out of this. There we go, 11. Coordinate system with an origin and a point. So each one of these now is its own little coordinate system. And we're going to do a little bit of a transposition of that. So what we're going to do is we're going to do a geometry transform. And this really tells you where we're going with, oops, that's the wrong one. And from a coordinate system to another coordinate system. So we have the existing one, the coordinate system that we've created. And we've got our geometry, which is the polygon or the surface. It doesn't really matter what we put in it. I'll just use this to be descriptive right now. And you'll notice nothing's appearing yet because we really don't have this other coordinate system. So this is going to take a few minutes to create, but really we have everything we need right now. We just don't have some little points out in space to attach this geometry to. So let's go ahead and make an array now, another set of geometry, which will be these things laid flat out into a 2D space. So we've got to create some functionality here. And so I'm going to do some sliders. I'm going to make 3 sliders, and I want to just kind of describe what these are going to do, and then hopefully you'll be able to see them played out in the math of the whole thing, or the visuals. So I'm going to go ahead and rename this node. I'm going to call this offset. Remember, when we lay these panels down, we're going to want to space them. We're going to have to tell it how many panel spaces we want, so I'm going to rename this one. And I'll just do number. And actually I should have changed these things so that they were solid decimals and limit the number of these. Oh, I could say 100. And then this last one is the part spacing, and that can just stay as a slider of any dimension. So this is the spacing between the components. Okay, so I'm going to do a little bit of geometry here, or Arab, I don't know what you'd call it, some cryptic manipulations to create this new coordinate system. But it's going to end up with points by coordinate. So I want to feed a bunch of these spacing values in to create a whole array of points out in space. And the first thing I'm going to do is create a sequence of numbers, and I'm going to use code block to put that in with. And I'm going to just duplicate that right away because we're going to use it again. And in this one, I'm going to write the code. I'm going to go from 0, ... to x. And I'm going to feed that with this number panel spaces. And this is going to make an array here. So let's see what I've done here. Step 0, we need 1 steps of 1. It wouldn't move for me. Let's just put a 3 in here to start with. And I'm going to feed this in to x. And I want you to see that we get now a series from 0, 1, 2, and 3. So we get 4 numbers. And we want to actually change these numbers so that we space out how far apart the array is. So we're going to just do another little piece of math. So I'm going to do number times space. Whoops. Oh, I meant times, not at. So I can't figure out what's going on there. So it's nice that you can put those in and do the math, and you still get these visuals to remind you what you're connecting here. So I'm going to add that to this, and let's look at what happens now. Now these numbers can, if I change this, let's say I go up as high as, let's say 20 or somewhere close. Now this sequence of numbers, if I can get it to show up here. Oh, it's like my mouse is out of sequence with the. There we go. So now it's incrementing at that 18.3. So the numbers are, I can change the range that I want that to be in. Okay, so we can now go ahead and do a little, let's go ahead and feed this in. I'm going to feed in this for a y value, and I'll feed this in for an x value. And let's really look at what we get here. And I'll have to probably back off here a little bit just to find out where it is. It's not showing up yet. So we have 4 points, and I'm not exactly sure where they're sitting. So what I'm going to do is, this is where the offset comes in really handy. So I'm going to do another code block. And in this, I'm going to put x plus y. And my y value is going to be that spacing value that I wanted to use. And my x value is going to be this number. And then I'm going to feed it into here. And now if we change this a little bit, we'll be able to see that we're pulling that array off. Okay, so I know this is a little bit hard to get a whole grasp on, and it's almost better now to, once you created it, to kind of like evaluate what you have on the screen. And we don't need a z because we want it to lay in the 0 reference plane, but it's arrowing out. So what I'm going to do is I need to get points by, I'm going to just swap that out with just an x, y one. I don't want x, y, z, I just want x, y. And I don't know if we have that. Oh, point. That's one of my problems. Oops. That's funny, I'm not seeing x, y. And I had it in my last definition, so I hate to, so we're just going to feed the z value. I'm just going to type in a number. And that number is going to be 0, so I'll feed it into this x. I'm really trying to get rid of that yellow. Oh, what's our problem here? Your inputs lie outside of the modeling range. Consider choosing larger settings. Oh, all right, so that's just a setup thing. Let's see if we can find that, because that would come up with U2. It's really a preferences. See how that, where it just tells us where to find that. I'm going to zoom in here, maybe we can see that better. So we're getting yellow because settings, geometry, working range, settings. Well, this might be it. We'll go to large. It's still not happy. Let's try large, extra large. Yeah, I'm not exactly, I don't know if that might change now if we did change some of these numbers. Yeah, let's see. I'll keep moving along and we'll see what might be the hang up there. Now, one of the things that's wrong here is we're actually seeing a single dimensional array, so we're only getting the shortest product. So we're going to make a little change to this, to our lacing, and we want to get the cross product. And now you see we have an array here, and we're going to take these polygons and flip them into this array. So just to review, all of this code block development we've been doing in the last few minutes here has been to come up with this array, this point system. And we have a lot of adjustment over here about how many that we have and how far we space them apart. So we can change the size of our grid. I'll bring them probably a little bit closer. And we can control how far it sets off from our main object. So that's a good start right now for that layout. And since we have that now, we're ready to take the origin that we had with the polygon, the coordinate system that we had established with all these polygons, and translate it back to these. Remember, we need this other context coordinate system. So we have to do a few things there. We have to do a coordinate system by origin. Yeah, let's see if that shows up. I want just by origin. And that's backwards, so I have to find that again. Dot by origin. And we're going to put in an origin point and get out a coordinate system. And that's what we want. So we're going to grab this one here. And we're going to put those points into it. And that really isn't going to visualize yet. I'm going to remove that one. And now we can try to stick this in and see if that'll fly. And there we go. Now we've laid out, now we've done what was a laborious task, I guess, the first time to go through. We took we identified all of the polygons, we made them solid, we put an origin point in them, we determined a surface normal point, we connected them to a coordinate system, and then we manipulated it onto another coordinate system that we created up here. So what we can actually do right away now is actually substitute out that polygon and put in our adaptive component. And we'll pick up that after the next clip, or in the next clip.